So now we're going to look at formulas. So formulas are combinations of symbols giving the type and the number of atoms. Often going to refer to compounds as binary, sometimes tertiary, so on and so forth. So what binary compound means is when you have two different elements combined. So here are some examples of some formulas. In this first one, we have NaCl. So there are two elements present, sodium and chlorine. Now, the subscripts present on these chemical formulas indicate the number of atoms. But notice, for this first one, NaCl, there are no subscripts. So if you don't see a subscript, you can assume there's just one of each of those atoms. So this chemical formula tells me there's one sodium and one chlorine. Looking at the next example, we have CH4, once again a binary compound. This would be carbon and hydrogen together. We use the subscripts to figure out how many atoms of each element are present in the compound. So carbon doesn't have a subscript, so we know there's just one carbon. But after hydrogen, we see this subscript of 4. So that means there are 4 hydrogens for every one carbon in this compound. The last example has 3 elements now. We have carbon, hydrogen, and oxygen. Once again, to figure out how many of each, we're looking at the subscripts. So 5 carbons, 12 hydrogens, and 2 oxygens. So now let's look at covalent compounds. So we're going to learn how to name them. So a covalent compound is a nonmetal with a nonmetal. So notice my nice color-coded periodic table with the nonmetals being in yellow. Once in a while, we will see covalent compounds between a semimetal and a nonmetal. So just be aware of that. It's not always just nonmetals. That's just the most common type. When we find a covalent compound, it's when the electrons are shared. Sometimes they're shared equally, sometimes not so equally. Covalent compounds are also often referred to as molecules. So when you hear the term molecules, we're talking about covalent, not ionic compounds. So how do you figure out, based off the chemical formula, if a compound is covalent or not? Well, find the elements present in said compound and see where they are on the periodic table. So nitrogen, for instance. Nitrogen in yellow here is a nonmetal. It is combined with oxygen. Oxygen right next door to him, also a nonmetal. So now, since we know we have 2 nonmetals, we know it's covalent. So why is it important to know if a compound is covalent or ionic when you're trying to name it? Well, there's different rules for naming covalent compounds than there is for ionic. With covalent compounds, you start by naming the first element. So in the example we just saw, N2O5, you would start by writing nitrogen. Then you find the second element present and name that one as well. But the second element isn't going to be oxygen. We're going to add an ending to the second element present, and that ending is going to be an IDE ending. You can see off to the right here is a table of how most of the nonmetals change when an IDE is added. For instance, we're looking at this nitrogen-oxygen compound. So when we add an IDE to oxygen, it doesn't become oxygenide. It actually becomes oxide. Same with nitrogen. If we needed to add an IDE ending to that, if it was the second element present, it would become nitride, not nitrogenide. So just be aware of that. Next, we need to add prefixes to indicate how many atoms of each type are present. So this is where the subscripts are going to come in handy. Looking at the prefixes, off to the right, I have them labeled 1 through 10. In this course, we won't see higher than 10 when we're actually naming a covalent compound anyway. So in the case of the example above, since there are 2 nitrogens, we would label that as dinitrogen. For the oxygen portion, since there are 5 of them, we would look at the prefix 5 and it would be called pentaoxide. So dinitrogen pentoxide. The correct name for that covalent compound. Now there are common names for a lot of the covalent compounds that we will be naming, but we're going to try to systematically name them. Let's try another example, CO2. Start by naming the first element. So C is carbon. Second step, name the second element, but add an IDE ending to it. So the second element is oxygen, so oxygen becomes oxide. Last but not least, we're going to add prefixes to each to indicate how many atoms. So carbon, there is no subscript after it, so we assume there's just one carbon atom. The subscript of 1 tells us it should be mono. For oxygen, there are 2, so in front of the oxide portion, we would write di. So we come up with monocarbon dioxide. Now, if you think about it, that doesn't quite sound right, because I'm sure many of you have heard of carbon dioxide, but never of monocarbon dioxide. So this is where we get our first exception. There's always exceptions to every rule. The exception is that the prefix can be dropped on the first element if there's just one, if it's mono. Okay, so what that means, if there's only one atom of the first element in that chemical formula, you do not put the prefix. You do always need the prefix on the second element, and you will need the prefix always on the first for numbers 2 on up. So Next, we're going to look at Cl2O7. So let's systematically go through it. Cl is chlorine, so that would be our first word, our first element. Second element, oxygen. Since it's a second element, we would change it to oxide. Next, add prefixes. 2 chlorines would be dichlorine. 7 oxygens would be heptaoxide. So dichlorine heptaoxide. Now notice it looks a little weird having 2 vowels right next to each other. So another rule, and this is just a spelling error, which I won't ever count you off for because I'm not the best speller myself, but if you have 2 vowels next to each other, an A and an O or an O and an O, it is just changed to O for the spelling purposes. It would just become heptaoxide. Now let's practice with some more examples. pH 3. Go ahead and pause if you want to try to come up with it on your own. I'm going to work through these kind of quickly. So pH 3, we have phosphorus and we have hydrogen. Hydrogen being the second element present, so it's going to become hydride. Next, we look at our prefixes. So you can see at the top here, we have the basic outline of how we name these. We have a prefix, the element name for the first atom present, and then prefix, and the second element has an IDE ending. So in this case, there's only one phosphorus, so you might start to say, oh, it's monophosphorus. But remember that rule. If there's only one of the first element present, you don't put the mono on it. So it's not going to be monophosphorus, it's just going to be phosphorus. The second element present, hydrogen, will be tri, because there's 3 of them, hydride. The next example, so there are 2 nitrogens, so the prefix is going to be di-nitrogen. The second element, present oxygen, there are 3, so it would be tri, and then oxide for that IDE ending. Notice the IDE ending is only on the second element present. Another example, SCl6. So S is sulfur. How many? There's just 1. Since it's the first element present, we are not going to use the prefix mono. So it will be sulfur, and then chlorine becomes chloride. Since there are 6 of them, the prefix going on that one will be hexa, so hexachloride. Now let's look at writing formulas of covalent compounds. So given the chemical formula, like we just saw in the previous slide, you need to be able to name the compound. However, you also need to go reverse. What I mean by that is if you are given the name, you need to be able to write the corresponding chemical formula. So let's look at an example. If you were given the name dinitrogen tetroxide, how would you figure out what the chemical formula is? Well, you can use the element name portion, nitrogen, and oxide to figure out the elements involved. So nitrogen has the symbol N. So you would look it up on the periodic table and see what its symbol is. Oxide, that's just the IDE form of oxygen. And when you look up oxygen on the periodic table, its chemical symbol is an O. So now that we have the chemical symbols, we just need to put them together with the prefixes involved. So what the prefixes are going to tell us are how many atoms of that element are present in the chemical formula. The prefix of di in front of nitrogen tells me there are 2 nitrogens. The prefix tetra in front of oxide tells me there are 4 oxygens. So putting that together, we get N2O4.